Alright, today is lesson 7.7, base E and natural logarithms. We're going to learn about this new number called E. Alright, I'm going to show you how to use it. This number is used a lot in arches and engineering, and a lot of things have to do with E, sound waves, a lot of stuff. Alright, okay, so our Pascal today is 25B still. We'll finish that up today. Alright, what the number E is, it's a number kind of like pi or the square root of 2. It's an irrational number. Alright, it's approximately 2.71828. It was actually discovered by a guy named Euler back in the 1700s, and it's applied in a lot of different mathematical fields right now. Some of the main things you need to remember, you need to know about E, is a new terminology. Alright, if we're using E as our base, then rather than writing log base E, we write natural log. The abbreviation is LN. It's the natural log. Alright? And so, for example, if I have the natural log of 4 is equal to x, that means that log base E of 4 is equal to x, which would also then mean that e to the x power equals 4. Okay, let's show you how to work with this. Your first skill is basically going to be taking and translating these things over into logarithmic form. So, instead of writing log base E, I'm going to just write ln. Alright? ln 8 equals x. ln x equals 5. Just getting used to those logarithms. Okay? And now, vice versa, we'll go backwards. This is a natural logarithm, so our base is e. And so, we just say e, this is a power, 0.7741 is equal to x. Over here, e to the x is equal to 10. Alright, that covers the first section in your worksheet today. Now the second section, we're going to apply the properties we learned in lesson 7.5 to simplify expressions that contain the e and all this stuff. Alright, step one. What I need to do here, first off, is take this and realize that that 3 is actually a power on the 10. So this is equal to the natural log of 10 to the third minus the natural log of 8. And recall, the subtraction within logarithms such as this actually means division. So this is the natural log of 10 to the third over 8. Now, think about 8. Isn't that's 2 to the third power. So when I look at this, I've got 10 to the third power over 2 to the third power. Since the powers are the same, I could consider this the third power of 10 over 2, which is 5 to the third power. Okay, so this is going to be the natural log of 5 to the third power. And I could go ahead and rewrite this now as 3 natural log 5. That's the simplified form of that equation right there. All right? Now that comes into play when you're working with trying to solve natural logarithms, such as these two examples. All right, let's take a look at the first example here. Okay, recall that natural logs and e are inverses of each other. So if I'm taking e to the natural log x power, that's going to equal just x. And if I'm doing the natural log of e to the x power, that's also equal to just x. So if I can get just e to a power or the natural log to a power on both sides, then I can go ahead and I can solve for x. Step one on this equation right here. I have 4e to the negative 2x power minus 5 equals 3. I'm going to move the 5 over, so I'm adding 5 to both sides. 4e to the negative 2x power equals 3 plus 5 is 8. I'm going to divide off that 4. E to the negative 2x power is equal to 8 divided by 4. Now I'm going to do the natural log of both sides. The natural log of e to the negative 2x power equals the natural log of 2. And using this property right here, I know that this is equal to negative 2x. And so now to figure out what x is, I just need to take this number, divide it by negative 2. So that's equal to the natural log of 2 divided by negative 2. Let me clear this out so I've got a little bit more room right here. I'll paste it to the next page. Okay, so now then to calculate this, I've got a calculator right here. All right. I need to do the natural log of 2. On this calculator, you'll see your natural log button right there. This one does not follow order of operations very well. That's the natural log of 2. Divide that by negative 2, and I get my answer right there. We'll need to round that answer, so negative 0.3466. Negative 0.3466. And of course, since this is a rounded number, I wouldn't use the equal sign here. I would use the approximate sign. All right? Now let's take a look at my next example for you here. Okay, in this example, oops, try that again. There, that's better. Move this out of the way. Okay, I have 3 natural log 4x equals 24. Once again, I just want my natural log on this side, so I'm going to divide both sides by 3. Natural log of 4x equals 24 divided by 3, which is 8. Now, to get rid of the natural log, I'm going to do e to the natural log of 4x power. Whatever I do to one side, I do to the other side. Over here, following our previous example on this page, all right, e to the natural log of x is equal to x. So e to the natural log of 4x is equal to 4x. And to get rid of the 4 and have only x, I'm dividing by 4. X equals e to the 8th divided by 4. So now let's calculate that. E to the 8th divided by 4. Okay. To get to e on this calculator, I've got to push the inverse. I'll put my 8 in first and then push this button. Okay, so that's e to the 8th power divided by 4. And so I get 745. Copy that. All right. Again. Just going to put it there. I hope you're enjoying this program today. There. Okay, so let's do our approximate sign. X is approximately 745.2395. All right, that's all I've got to show you today about lesson 7.7, working with natural logs and base E.